Now in this question, we need to write a method to partition a linked list around a value x, such that all nodes less than x come before all nodes greater than or equal to x. So here, if x contains within this list that we are looking in, the values of x only need to be after the elements less than the x. So partition element x can appear anywhere in the right partition. It does not need to appear between the left and right partitions over here. And here you need to take into account that there is no obligation about the order of nodes. So we can change the order of elements over here. So the logic over here is very simple. So we are going to start through the linked list and put the elements that are less than the x to the left and put the elements that are greater than the x on the right. Now let's say we have a linked list like this and we want to partition this linked list around 10. Now the first thing that we are going to do, we are going to create temporary node, which is the current node, and assign the first node's value to it. And then we are going to set tail reference to this node over here. Then we are going to set the current node's next reference to null. Then inside loop, we are going to continue to loop this through linked list, and we are going to check that. If the current node is less than x, then in this case we are going to add this node at the beginning of linked list. Otherwise, we are going to add it at the end of linked list. Now in this case, we have started with the 10. So this means that we are going to go to the node 1 and complete this operation over here. So after doing so, our linked list will look like this. So node 1 will be added to linked list like this. Then we are going to continue to the node 2. In this case, we have 3 in our node. So this means that we are going to compare 3 with 10. We see that it's less than 10. So this means that we are going to create this node and add this node at the beginning of this linked list over here. So 3 is less than 10, so it's going to be added at the beginning of linked list like this. So after addition, our linked list looks like this. Then we are going to continue to the next node. So in this case, we have 9 over here. So 9 is less than 10. So this means that we are going to add this one at the beginning of linked list because this is less than 10. So after addition, our linked list looks like this. Then one more time, we are going to continue to the next node. Now in the next node, we have 10. So 10 equals to 10. What we are going to do in this case? So in this case, as we said before, if the partition element exists in the linked list, this means that we are going to add this one at the right of linked list because this node has to come after the nodes that are located on the right, left. So this means that we are going to add this one at the end of linked list over here. So as we mentioned before, this node over here does not have to be between the left and the right partitions over here, so it can be anywhere on the right partition. So this means that node 10 will be added at the end of this linked list over here. Now after addition, you see that our linked list becomes like this. So the next reference of node 1 was null, now it's point to node 4 over here. Now the next reference is node 4 is null, this because at the moment this is the last node in our linked list over here. Now then we are going to continue to the last node. So in this case, we are going to stop over here because we have reached the last node and we are checking that if 15 is greater than 10 or not. So it is greater than 10. This means that we are going to add this one at the end of linked list over here. Now with this, we have successfully completed partition of this linked list around 10 over here. So as you can see, the elements that are less than 10 are located on the left, which are 9 and 3. The elements that are greater and equal to 10 are located on the right, which are 11, 10, and 15. Now with this, we have successfully completed partition of this linked list around 10. So this is how the algorithm of partition looks like. Now based on this logic over here, we are going to create a method which complete partition in practice. So let's head over to Java and create it over there. Now inside this questions class, I'm going to create question number 3, which is partition. So before we have created question number 2, which is end to last, and question number 1, which is deleting duplicates. Now here we are going to implement question number 3. Now here I'm going to declare our method like this. So the return type of our method will be linked list and the name of method will be partition. And as a parameter, it will take 2 parameters. The first parameter will be linked list, the one in which we want to do partition, and the second parameter will be integer x. So we are going to do partition around this x over here. Now the first thing that we are going to do, we are going to create current node and set head value to this current node over here. So node current node is going to equal head. Then we are going to set the value of head to tail over here. So it's going to be like this. Well, linked list of tail is equal to linked list head. Then inside loop, we are going to loop through this linked list and check that if the current node is greater than x or not. So in this case, while current node is not null, this means that we are going to continue until the end of linked list. So while current node is not null, in this case, we are going to create a new node over here, which will be the next node, and set current node dot next to this new node over here. So this new node keeps the value of the next node in our linked list. Now then I'm going to write if condition like this. If current node dot value is less than x, it means that we are going to add this node at the beginning of linked list. So to do so, we need to create a reference from this node to the head, which is the first node. So I'm going to set the next reference of this node to head, and head also has to point to this node over here. So head will be point to current node. Now with this, we have successfully inserted an element at the beginning of linked list. Otherwise, we are going to add it at the end of linked list. So we know that to add an element at the end of single linked list, in this case, the last node has to point to this node over here, and the tail has to point to this node over here. So I'm going to do it like this. Tail.next. So this is the last node's next reference is going to set to current node, has to reference to current node over here. Then after doing so, we have to continue to the next node. So that's why I'm going to set next node's value to current node. So in each step, it's going to continue to the next node. Then at the end, when we have finished our loop, we have to set the tail.next to null, because this is going to be the last node in our linked list. And then I'm going to return linked list over here. Now with this, we have completed our method. Basically what we are doing over here is we are looping through the linked list and checking that if the current node's value is greater than x or not. So if it is less than x, it means that we are going to add this node at the beginning of single linked list. If it is greater than or equal to x, it means that we are going to add it at the end of single linked list. So with this, we can partition this linked list around x. So the elements that are less than x are located at the left, and elements are greater than x are located at the right. Now let's see how this is working in practice. So here inside main class, we have created our linked list like this. So this is our linked list. So in our linked list, we have 5 elements. So first I'm going to call traversal method to see our linked list. Then we are going to call partition method. For example, we are going to do it around 4. And then again traversal method to see the both outputs in the console, and we can easily compare them there. Now let's run our code. Now you see that initially our linked list was like this. Then after partition around 4, linked list become like this. So here you can see that the numbers that are greater than 4 are located on the right, which are 9, 5, and 10. And the numbers that are less than 4 are located on the left, which are 1 and 2. So as we mentioned before, the order of numbers does not matter over here. So here you can see that we just need to partition the around x over here, which is 4 in our case. So as you can see, we have implemented our method successfully. Now let's see what's the time and space complexity for this method over here. So for this method, the time complexity will be O(n), because in this case, we are looping through all elements of the linked list and checking that if this value is greater than the x or not. So we know that looping through the linked list takes O(n) time complexity, so that's why the time complexity for this method will be O(n). Now the space complexity is O1, because in this case, we have not performed any space consuming operation over here. We have just looped through the linked list and checked the values. So that's why space complexity will be O1. Now with this, we have come to the end of this lecture. So hopefully everything is clear about this question over here. Now see you in the next question.